Every single time we announced a new product, the demand for every single generation increased and increased and increased. And then, one generation, it hockey steps. We stick with it, we stick with it, we stick with it. Kepler, and then Volta, and then Pascal, and then Volta, and then Ampere. And now, this generation of accelerated computing, the demand is literally from every corner of the world. And we are so excited to be in full volume production of the H100. I want to thank all of you for your support. This is incredible. H100 is in full production, manufactured by companies all over Taiwan, used in clouds everywhere, enterprises everywhere. And let's take a look at a short video of how H100 is produced. It's incredible. This computer, 35,000 components on that system board, 8 Hopper GPUs. Let me show it to you. Whoosh. All right, this, I would lift this, but I still have the rest of the keynote I would like to give. This is 60 pounds, 65 pounds. It takes robots to lift it, of course, and it takes robots to insert it because the insertion pressure is so high and has to be so perfect. This computer is $200,000. And as you know, it replaces an entire room of other computers. So this, I know it's a very, very expensive computer. It's the world's single most expensive computer that you can say, the more you buy, the more you save. This is what a compute tray looks like. Even this is incredibly heavy. See that? So this is the brand new H100 with the world's first computer that has a transformer engine in it. The performance is utterly incredible. Hopper's in full production. We've been driving computing, this new form of computing, for 12 years. When we first met the deep learning researchers, we were fortunate to realize that not only was deep learning going to be a fantastic algorithm for many applications, initially computer vision and speech, but it would also be a whole new way of doing software. This fundamental new way of doing software that can use data to develop, to train a universal function approximator of incredible dimensionality. It can basically predict almost anything that you have data for, so long as the data has structure that it can learn from. And so we realized the importance of this new method of developing software, and that it has the potential of completely reinventing computing. And we were right. 12 years later, we have reinvented literally everything. We reinvented, of course, we started by creating a new type of library. It's essentially like a sequel, except for deep learning, for neural network processing. It's like a rendering engine, a solver for neural network processing called cuDNN. We reinvented the GPU. People thought that GPUs would just be GPUs. They were completely wrong. We dedicated ourselves to reinventing the GPU so that it's incredibly good at tensor processing. We created a new type of packaging called SXM and worked with TSMC on CoWoS so that we could stack multiple chips on the same die. NVLink so that we can connect these SXM modules together with high-speed chip-to-chip interconnect. Almost a decade ago, we built the world's first chip-to-chip SerDes so that we can expand the memory size of GPUs using SXMs and NVLink. And we created a new type of motherboard we call it HGX that I just showed you. No computers has ever been this heavy before or consumed this much current. Every aspect of a data center had to be reinvented. We also invented a new type of computer appliance so that we could develop software on it, so that third-party developers could develop software on it, with a simple appliance we call DGX. Basically, a giant GPU computer, DGX. We also purchased Mellanox, which is one of the great strategic decisions of our company, because we realized that in the future, if the data center is the computer, then the networking is the nervous system. If the data center is the computer, then the networking defines the data center. That was an incredibly good acquisition. And since then, we've done so many things together, and I'm going to show you some really, really amazing work today. And then, of course, an operating system, if you have a nervous system, a distributed computer, it needs to have an operating system. And the operating system of this distributed computing we call Magnum I/O, some of our most important work. And then all of the algorithms and engines that sit on top of these computers, we call NVIDIA AI. The only AI operating system in the world that takes data processing, from data processing to training to optimization to deployment and inference. End-to-end deep learning processing. It is the engine of AI today. Well, every single generation since Kepler, which is K80, to Pascal, Volta, Ampere, Hopper, every 2 years, we took a giant leap forward. But we realized we needed more than even that, and which is the reason why we connected GPUs to other GPUs called NVLink, build one giant GPU, and we connected those GPUs together using InfiniBand into larger scale computers. That ability for us to drive the processor and extend the scale of computing made it possible for the AI research organization, the community, to advance AI at an incredible rate. We just kept pushing and pushing and pushing. Hopper went into production August of last year. August 2022. 2024, which is next year, we'll have Hopper next. Last year, we had Quantum. 2 years from now, or next year, we'll have Quantum next. So every 2 years, we take giant leaps forward. And I'm expecting the next leap to be giant as well. This is the new computer industry. Software is no longer programmed just by computer engineers. Software is programmed by computer engineers working with AI supercomputers. These AI supercomputers are a new type of factory. It is very logical that a car industry has factories. They build things that you can see, cars. It is very logical that computer industry has computer factories. You build things that you can see, computers. In the future, every single major company will also have AI factories. And you will build and produce your company's intelligence. And it's a very sensible thing. We cultivate and develop and nourish our employees and continue to create the conditions by which they can do their best work. We are intelligence producers already. It's just that the intelligence producers, the intelligence are people. In the future, we will be intelligence producers, artificial intelligence producers. And every single company will have factories. And the factories will be built this way. This translates to your throughput. This translates to your scale. And you will build it in a way that is very, very good TCO. Well, our dedication to pursuing this path and relentlessly increasing the performance. Just think, in 10 years' time, we increased the throughput, we increased the scale, the overall throughput across all of that stack by 1 million x. 1 million x in 10 years. Well, just now, in the beginning, I showed you computer graphics. In 5 years, we improved the computer graphics by 1,000 times. In 5 years, using artificial intelligence and accelerated computing. Using accelerated computing and artificial intelligence. We accelerated computer graphics by 1,000 times in 5 years. Moore's law is probably currently running at about 2 times. 1,000 times in 5 years. 1,000 times in 5 years is 1 million times in 10. We're doing the same thing in artificial intelligence. Now, question is, what can you do when your computer is 1 million times faster? What would you do if your computer was 1 million times faster? Well, it turns out that the friends we met at University of Toronto, Alex Krzyzewski and Sutskever and Ilya Sutskever and Jeff Hinton, Ilya Sutskever, of course, was the founder of OpenAI, and he discovered the continuous scaling of artificial intelligence and deep learning networks and came up with the ChatGPT breakthrough. Well, in its general form, this is what has happened. The transformer engine, and the ability to use unsupervised learning, be able to learn from a giant amount of data and recognize patterns and relationships across a large sequence. And using transformers to predict the next word, large language models were created. And the breakthrough, of course, is very, very, very clear, and I'm sure that everybody here has already tried ChatGPT. But the important thing is this: we now have a software capability to learn the structure of almost any information. We can learn the structure of text, sound, images, their structure in all of this, physics, proteins, DNA, chemicals. Anything that has structure, we can learn that language, learn its language. Of course, you can learn English and Chinese and Japanese and so on and so forth, but you can also learn the language of many other things. And then the next breakthrough came, generative AI. Once you can learn the language of certain information, then with control and guidance from another source of information that we call prompts, we can now guide the AI to generate information of all kinds. We can generate text to text, text to image, but the important thing is this: information transformed to other information is now possible. Text to proteins, text to chemicals, images to 3D, images to 2D, images to text captioning, video to video. So many different types of information can now be transformed. For the very first time in history, we have a software technology that is able to understand the representation of information of many modalities. We can now apply computer science. We can now apply the instrument of our industry. We can now apply the instrument of our industry to so many different fields that were impossible before. This is the reason why everybody is so excited. Now let's take a look at some of these. Let's take a look at what it can do. Here's a prompt, and this prompt says, "Hi Computex." So this is, we type in the word, "Hi Computex, I'm here to tell you how wonderful stinky tofu is. You can enjoy it right here in Taiwan. It's best from the night market. I was just there the other night." Okay, play it.
Hi Computex. I'm here to tell you about how wonderful stinky tofu is. You can enjoy it right here in Taiwan. It's best from the night market.
The only input was words. The output was that video. Okay, here's another prompt. Taiwanese, we tell this AI, okay? We tell this AI, this is a Google text-to-music. Traditional Taiwanese music, peaceful, like it's warm and raining in a lush forest at daybreak. Please. You can tell. Okay.